Yeah. This is Algebra 11 Mastery. Shapes and distributions. I love these titles. You know, they always tell us like, be more engaging to your students. And it's like, what's the section called? Shapes of distributions. Actually, it's cool. I promise you, it's cool. You just have to put in a little work is all. Okay, essential question. I promise not that these essential questions aren't stochastic. Okay, what's up with the shape of a distribution? What a beautiful sentence. What's up? What does that even mean? What is up? Well, what is up on a shape of a distribution? And this is honestly something you've already done. I believe I said, way back in the days of yore, when you used to eat red hot Cheetos while playing video games late into the night. Wait, that's now. You still do that now. Anyway, here it is. We have symmetric distributions. This thing's called a histogram. What's a histogram? You have intervals on the x-axis. So you have a number line, and each of these intervals is the same width. So if it was like ages, it'd be like from 1 to 5, 6 to 10, 11 to 15, something like that. And then you have some measure on the y-axis, right? So like it could be, you know, whatever it may be, the amount of homework you have. Maybe it gets worse as you get older and then it gets easier. And this is called symmetric because you could draw a line of symmetry, which I'm not even going to attempt. Well, I'll try it. If you draw a line of symmetry, the left side and the right side are reflections of one another. So the data on the right of the distribution is approximately a reflected, I don't care if I say mirror, image of the data on the left of the distribution. Beautiful, it looks so good. Okay, now let's take a look at skewed left. Dun, dun, dun. When you were in 6th grade, I said you climb the ladder and then you slide to the left. That's skewed left. And the reason it's skewed left is because the tail of the graph extends to the left. What's actually going on here is most of the data are here. This is where most of the data are centered. And then you have this tail of less data going off to the left. Most of the data are on the right. Okay, skewed right. Skewed right, you climb the ladder and then you go, whee! You slide down to the right. And the tail of the graph extends to the right. And most of the data, therefore, are on the left. Most of the data are on the left. And I know for some of you who are like, why don't you highlight symmetric too? Do it. Okay, there you go. Okay, do you feel better? Do you feel better? Do you feel like everything is just making sense? Okay, good. All right, let's take a look at a real distribution and let's talk about the shape of it. Well, let's see. We have percent daily change in oil price. Now, this probably doesn't matter to you very much, but it matters to your parents who are driving them cars, unless they have a Tesla because they're super progressive. I'm just jealous. Teslas are cool. I just think, like, why can't I have an electric car? Okay, the last electric car I had said Barbie on the side. But anyways, it's more important that we figure out the shape of this distribution. What do you think it is? Skewed left, skewed right, or symmetric? Okay, it's symmetric. Come on, right? This is a symmetric data set because you could draw a line of symmetry down the middle and it would be roughly symmetrical on both sides, or reflection, right? Symmetric. And what is this actually telling us? That every day, sometimes the price of oil goes down, right? Negative. Most of the time, let's see this case that's here in the middle, where you have the most data concentrated. Most of that data is positive. That means the price of gas, for instance, has generally gone up. There have been, of course, times it goes down. And as you get further away from this concentration of data, you can see that it goes down and down. So sometimes it goes way up, usually because there's like an oil refinery or I don't know, they just want to make more money. And sometimes it goes way down because there's something that's happened like COVID and everybody's worried about the economy. So we're going to start using these kinds of descriptions on real data sets. And that's the point here, is to move towards real data sets, use mathematical analysis to actually say something important about life. Okay, choosing appropriate measures Make sure you choose the appropriate measures, everybody. Well, what kind of measures are we talking about? We're talking about measures of center, the mean, the median, and the mode, and measures of variation, which of course we've talked about now, the standard deviation, and using a box and whisker plot, right? Using IQR, right? Interquartile range. But anyways, when a data distribution is symmetric, right here. Oh yeah, nice and symmetric. Looks so, that was actually a really good highlighting of yellow. Look at that. Okay, you use the mean in this case. And the reason for that is because there's not a concentration of data on the right or the left that is going to, there's not a tail which is pulling the data away from where most of the data are centered. Let's just think about this for a minute. Okay, most of the data is off here to the right. The problem with using the mean is this tail over here is pulling the mean to the left. And so the median is actually a better measure of center in the case that you have a skewed data set. And the same thing goes, analogy is on the right. If you have a skewed right graph, then the mean is being pulled to the right by this tail of data that's off to the right. And so therefore the median becomes the better measure of center. By analogy, the standard deviation is the best measure of variation in a symmetric data set. Why is that? Well, think about the mean. The mean is part of finding the standard deviation. After all, the standard deviation is a measure of how far on average the data are from the mean. And so the mean implies that we use the standard deviation for the measure of variation. But when the data distribution is skewed, like I said, we don't use the mean, we use the median because that mean has been compromised by being pulled off to the side by the tail. What variation deals with the median? Well, when we use the 5-number summary, which is the, you guys remember, it's the least value, greatest value, median, first quartile, third quartile. So it's kind of like using the IQR, the interquartile range. So that way we have this medians telling most of the data are centered here, right? We don't want to say they're centered here because then you're getting away from where most of the data are centered, which is off here to the right. Okay, let's look at a real world example. Distribution of age at time of death. I just wanted to pull out something real optimistic. But in all seriousness, these are the data that we look at, right? And this distribution has been changing as time has gone on. So you can see females are in red and males are in blue. And along the x-axis, we have age at the time of death. And you can see that that's ranging anywhere from at birth, which unfortunately we have some deaths here, all the way to like well over 100, right? And then it's number of deaths per 100,000 people, okay? All right. Now, as you can see, that most of these are way off to the right. Most of the data is way off over here to the right. And as time goes on, we're getting better and better at different medical technologies and preventative measures that people can take to live longer lives, which just seriously includes taking a walk every day. If you are indeed just eating Cheetos, playing video games all day, every day, it's okay when you're 13 or 14. But it's something if you get into the habit of doing some physical activity every day, you know, listen to Mr. Shea, okay? Listen to Miss Buckley. Then it can really actually help you sustain a longer life. So this will actually probably for you move off to the right, and we're making technological progress on actually preventing aging. So that's cool. Okay, now look at these data sets. How would you describe the shape of the distribution? Symmetric, skewed left, skewed right. These are both skewed left. They're both skewed left. Very few people who unfortunately lose their lives very early in life. Like I said, you take care of yourself, you're going to be in good, the probability you'll have a good long life is very high. But we're more interested in just looking at something that's a real distribution. These are real data. It comes from the US Social Security Administration in 2013. And if it's skewed left, then let's talk about the measures that we would use. If this is skewed left, what would be our measure of center? Okay, measure of center. Well, what's that tail going to do? This tail to the left is going to pull that mean down from where the median would be. And because it pulls it down, it's best to use the median, not the mean. Now, what would then be the analogous measure of variation, or bar? It would be the IQR. They're saying 5-number summary, so we'll say 5-number summary, but then I'm going to put in parentheses 5-num, whoa, got to the M before the N and the U. But what else is new? Okay, 5-number summary, sum with 2 M, so it doesn't look like sum as an add, which is the IQR. So an easy lesson today. I think that honestly, though, it's very visual, and it should make some sense how you find or which measure of center and which measure of variation you should use depending on what the shape of the distribution is. You're all amazing. I hope you're all doing well, and I'll talk to you later. Bye.